Now let's try to understand the second type, which is continuous and categorical. Now this is going to be interesting. So continuous and categorical, I told you that we can use a bar plot. Also, we can use a box plot. Let's see how it does. Now, if I do sns.bar plot, let's first draw the diagram, then we'll try to figure out what it means. Let's say x is equal to my species and my y is equal to, let's say, any of the columns. What are the continuous columns which I had? Did I save it? No. So let me save those columns. Simply have to do this. Save it in a variable. Call the variable again. And I can simply look at sepal length like this. Oh, I have to also mention what is the data I'm pulling out from. I did not mention the data here. What do these bars represent? This bar, the top height of the bar, this is almost 5, this is almost 6, this is almost 6.5. The bar height, basically this value, basically represents the average value of sepal length. It's possible to find out the average value of sepal length because sepal length is continuous in nature, it's a float. The average value of sepal length with respect to the category, which is iris setosa. Okay, let me quickly write a code, simple line of code. We have already done it slicing to help you explain better way. So if I do df of, now if I want to suppose I want to first extract all the data points with respect to setosa, what will I do? I'll do something like this, df of species equal to iris setosa. This is what I'll do. I'll get all the data points with respect to only iris setosa. Now I do not need all the columns, right? I only need what I'm analyzing is sepal length. So what I'll do, I'll simply do sepal length. And then I need the average value. Dot, what is it? 5.000599. Similarly, I can change this particular category to get another value. So this 5.0559 is nothing but this height. And this, which you see here, is nothing but the standard deviation, the deviation of it. It simply means the deviation is not that much. We have a fairly good number of data points for each category. And that is 50, 50, 50. 0.35 is the standard deviation. Okay, so that is what it means. Now, if I want to explain this in a faster way, I'll simply do a group by, right? How will I do it? I'll get the average of all the categorical sepal length value. So what I'll do, df.group by, I'll do species. Okay. Next, I only want the sepal length. And I'll do simply mean. Now, if you look at this, what does it mean? Very simple. The same thing I've done here. With respect to iris setosa, it is 5.006. If I round this off, this will become 6. Makes sense. Iris versical is 5.93, which is very close to 6. And this is 6.5, as I told you already. It lies between 6 and 7. So 6.6 or 6.5. Right? The same thing is being done here. Now, we all know that this is a series. So what I can do here is I can simply do a dot plot. Now this is called as pandas plot. Plotting is not only present in matplotlib or seaborn, which are two separate models you have to call for plotting. You can do simple plots using pandas plot also, because df is nothing but pandas data frame, right? So dot plot, if I do kind equal to bar, it will take these indexes as the x-axis and the values as the bar heights. Same thing, just that two different ways of expressing it. Because when you use SNS, it will be all the bars will be of different colors, whereas here it will be of the same color. Different ways of doing it. I can also use matplotlib also. Seaborn, the syntaxes are pretty much consistent, so it becomes easier to understand. However, if I want to change figure heights and all those things, then you can do plt.figure fixed size is equal to, let's say, 6 cross 6, 6 length and 6 height. It looks a bit elongated, so I can increase the width more. This represents the width, represents the height. But I did this only for one column, right? So what did I do here? I had 5 columns. 4 of them are continuous. The 5th column was a categorical column. So next, after evaluating all the continuous sort of data, now I'm evaluating continuous and categorical. And I only have one category column here. So I'll evaluate X1 with the categorical, X2 with the categorical, X3, X4 the categorical. Categorical column itself is X5. So we have 4 and whatever it is, 5. So we'll have 4 different diagrams. For continuous plots, I already had a pair plot which did all the combinations and give it to me. But for this, what do I do? Again, the same concept which I used in the previous video. And please go to the previous video if you want to get it from the basics. We'll use plt.subplot, right? Okay, so we have all the column names with me, and I also have object column, right? My object column is nothing but, what do I call it? Species, right? You already know that. Now, let me create a function. But before getting a function, let me write the logic first. Okay, what was the logic? Rows and columns. So we said, okay, we'll plot it in a grid. We have 4 diagrams to plot. I can do it in 4 columns easily. Let me keep it straight. I'll use 3 columns. So C is equal to 3, I'll keep. Okay, I'll keep columns. 3 columns will create the grid. So if I have 3 columns, now how many number of rows will I use? That will depend on total number of graphs kitne honge. I have 4 continuous columns, there will be 4 different graphs. So total T is nothing but my length of the continuous columns, which is 4. Okay. Now rows will be what? Row will be equal to T divided by C, total divided by C. But here it is 4 divided by 3, which is 1.333. If I would have had 6 length divided by 3, I would have easily got it 2, right? Very simple understanding. 6 divided by 3 is 2. So we have 3 columns and 2 rows. Columns and rows. This is total. But here I have 4. This will become 1.33, whatever it is. But still I need 2 rows, na? Because the last 2 grids will be empty. It's fine, no problem. The numerator, the total, does not need to be perfectly divisible by the number of columns. So in that case, what I'll do? 1.33 को मैं increase कर दूंगा, right? Very simple. By 1, what I'll do? I'll simply do T by C of if R. So what I'll do? I'll simply check whether R the integer of R is equal to the float of R or not. Right? So if int of R, if I do equal to R, right? Which simply means that it is as it is, right? 6 divided by 2. So if I do int of R, suppose say R is 6 by 3, which is 2. So int of R, and whenever we divide it, please remember guys, it always gives you a float. Huh? Please remember this, it always will give you a float. Even if you divide 2 integers, it will always give you a float. Maybe it's 2.0, but it is a float. So int of R is equal to R means what? 2 is equal to 2.0. But if this is 1.333, my int of R will become 1 and it will be not equal to my actual R. That is where I can use the concept of increasing by number 1. So I'll do int of R not equal to R. Then what will happen? R is equal to int of R plus 1. This will become 2. Int of R is 1.33. Int of 1.33 will always give you the lower, the integer value out of it, right? Which is 1. Even if it's 1.8, it will still give you 1. So 1 plus 1 will become 2. Else, I'll simply do R is equal to int of. I need R to be not a float because PLT subplot will always take integers. So once I have the concept of this, now I can automate. plt.rc params, right? You have to bear with me guys with this, because if I automate this, if you can automate this, you'll be able to use this logic everywhere. So I have this will be equal to width comma height. So width is, you can keep it fixed 20. Height will depend on number of rows which we have, right? So I'll pick 5 size for each row. Right. Once I have this again, what I'll do next, I'll initiate count is equal to 1 to iterate for increment actually for I int cont underscore calls. This is where the game begins. First, I have to specify on which segment do I want out of the grid I want this particular figure. So it is our row number of rows, number of columns. You have to figure it out, comma, which is your count. And here you will do SNS dot bar plot. What will be your X? X will be your object column, because that is the categorical column, comma, Y will be a continuous column. The first continuous column is sepal length. For here it is I, comma, data is equal to TF. This is what you're going to do. Once this is done, you can initiate, you can increment it to 1, so that in the next loop it becomes 2. It will plot it in the 2. Okay, I believe that is true. Now, can I convert this to a function? Yes. Tab def create a function which I've already discussed. Def of, let's say, plot multiple bar plots. What do I need here? I need the continuous columns information first, and also I need the data frame. Also, I would need the object column information, which means that if I use this function, I'll be able to do multiple bar plots for any number of continuous columns with one particular column of categorical column. That is what this basically means. Okay. So I can copy paste this code in a different project and run it. That is what the beauty is, guys, of creating. This is object-oriented programming. Okay. So this df, I've already used the default same variables here, so it's fine. Let's see if this works. Oh, I think I did not run the previous. Oh, spelling itself is my bad. This can be anything. It doesn't really matter. Here I have an error. What does the error say? Figure is not defined. RC params. Let me check the syntax. Okay, I think I had to put a quote here. Yeah, that's my bad. Okay, so once we have this, now you can see here, we have the same bar plots for all the different continuous columns. What do we see here? With increase in the species, my average value of sepal length is increasing. Here, it means that as I move from Iris setosa to versicolor to virginica, average sepal length is increasing. However, my sepal width, right, is maximum for Iris setosa, but is slightly lower for versicolor, and again for virginica it's slightly higher. So basically your sepal width and sepal length, both of them are not increasing hand in hand. For here the sepal length is minimum of the tree, here it is sepal width is maximum, so it's kind of an elongated, I believe, leaf. Petal length significantly increasing, whereas for petal length and petal width, now, as the width increases, the length is also increasing for all the different species. So many things we can infer from this particular diagram. And if there are changes in the median or mean with respect to different categories, it's good for us because it means that it's capturing patterns. For Iris setosa, the petal length is significantly lower than Iris virginica or Iris versicolor. And that is where we saw a different clustering of data points for Iris setosa, because it was on a lower, slightly significantly lower in size than the other two species. Now this by default bar plot, this height which you see by default, it gives you the mean value, the average value, and I showed it to you. If I want to show the median also, that's also you can do. All I have to do here is comma inside the bar plot. There's an argument called estimator, and to equate it to np.median. That is what you have to do. And if I do that, it will give you the median values instead of the mean values. Okay, same thing. I can in fact automate it whether you want mean or median. Let's say if I can simply say here estimator. Okay, by default, let's say I'll just put it as EST. Okay, so if EST equal to default, I'll use this. Okay, and I'll remove this out, or I can put it as if EST is equal to median, then this median, else So this is default, another one is median. By default, I'm keeping it default. Why? Because if I want that mean, I don't want to, use the default argument. That is how developers have actually built all these functionalities behind. Why are there default values there? So that you don't have to keep on writing them again and again as a person who is a data scientist or an analyst or a person who is doing any analysis in his own domain. All these are default values. Okay, no problem. So once we have this, my function is slightly changed. Now, if I simply do this, so this is mean. Whereas if I specify it, I want median values. So then I have to specify it here in the fourth argument. Then it will give me the median values. So here median are not that much different. It is evident from actually this. Okay, if I simply do the same code and do it with respect to median, not much difference. See? Both of median and median are almost same. When a mean and median are same, it means that the distribution is pretty much good. Okay, so last category which is there, which is called as categorical and categorical. And this is something which we'll evaluate in the next session. Okay, guys, thank you so much. So today, what did we learn? We learned the bivariate analysis for two special categories. One is continuous and continuous, and the other one is continuous and categorical. We also understood how to automate the process of selecting all the continuous columns from your data frame and analyzing it with respect to a categorical column with the help of a bar plot. We can also do box plot with your continuous column with respect to a categorical column, and we'll do the same thing in the next session. Okay, and there also we'll try to evaluate categorical and categorical. Okay, so the next session we'll also do a recap of a bit of categorical and continuous and also the categorical and categorical plots. Okay, guys, so I hope you enjoyed today's session, and I really hope that you've been learning from my previous videos as well. I'll keep on connecting with you almost every single day. Please like, share, and subscribe, and check out my other playlists, which I mentioned in the description below. See you in the next video.